If the x and y are positive integers and 2003x is equal to 2004y, what is the least possible value of x? Well, 2003x equal to 2004y, we can isolate for x, I guess. The least possible value of x. Okay. Well, both of them are integers, so we have to somehow see if we can isolate for one. Let's say isolate for y. Now, in my opinion, the most challenging thing about this is to recognize that 2003 is prime. And what a little bit of advice I always give is that if you are taking a math contest in a particular year, learn everything there is to know about that year. Like, for example, if you were taking a math contest in 2003, learn everything there is to know about that number, because math contests have a tendency to take the year that the contest is being held and make questions about it. So you should know when you walk in that 2003 is prime. Because it's prime, that means that this x has to divide 2004, because 2003 won't be able to. So x has to be some multiple of 2004n, let's say. And I think that's it. And then they want the least possible, so the least possible value would be when n equals 1, and therefore x equals 2004. So 2004 is the answer to this question. An integral triangle is a triangle with positive integral side lengths and a positive area. Such a triangle can have a perimeter as small as 3. What is the next smallest possible perimeter of an integral triangle? Well, since 3 is the smallest, let's try 4. Let's see if we can make a triangle with 4 as the perimeter. 112 perhaps? But 112 will fail because there's something called a triangle inequality. Triangle inequality. And that states that two sides, if you add them up, have to be greater than the third side. And a 112 would fail that. It would be 1 plus 1 is equal to 2. So there's no way you can make a triangle like that, right? It would basically be like this. So that fails. So 4 is out. Because remember, all sides have to have integer side lengths. And I can't think of any other integer combinations than 112, right? I mean, if you chose 1 and 3, then it'd be 0. 1, 3, and 0, and obviously 0 can't be a side length. Okay, so let's move on to 5 as a perimeter. Prime 2, 2, 1, and that immediately, you can see works. It satisfies the triangle inequality. So, therefore, 5 is the answer to this question. In the diagram, one side of a 30-degree inscribed angle is the diameter of a semicircle of radius 3. What is the perimeter of the shaded region bounded by the inscribed angle and its intercepted arc? All right, so we want the perimeter. So this side we already know is 6, so we'll put that there. And then we're going to have to add this side. Well, I just call it H for, I don't know why I'll call it H, because it looks like a hypotenuse. And then this, of course, is an arc. So I'll just write A for arc. So that's what I have to figure out. Okay, so where do I start here? Okay, well, I'll connect the center to here, and when I do, that is also 3, since that's the radius. So let me just draw that here like that. So this is 3, this is 3, this is 30 degrees. Because this is isosceles, that's also 30 degrees. And therefore, this angle would be 180 minus 180 minus 60, which is 120. Yeah, 120. Okay, and then if I cut it in half like that, then it becomes, I'll just draw it again, it becomes a 30, 60, 90 triangle. and that's 3. And then I'm interested in this side here. So I'll call that x. And as you guys know, the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3, I believe. Yeah. So root 3 and 1. Those are the ratios. So using that ratio, x over 3 would be the same as root 3 over 2, if I've done that correctly. And therefore x is 3 root 3 over 2. So that's x, and then we want the full length to get h, so therefore h would be 3 root 3. So there we go. So perimeter is 6 plus 3 root 3, and then of course the a, which we will now figure out. Okay, so now we got to figure out a. Well, we had calculated that that angle was 120. So if that's 120, then that means this angle in here has to be 180 minus 120, which is 60 degrees. So that means this arc represents 60 degrees of the total, which would be 360. So that arc would be 60 over 360. That's the ratio of the full circumference. And the circumference is pi times diameter. So that would be pi times d. D in this case is 6, I believe. So that gives me just pi, I guess. So that means perimeter is equal to 6 plus 3 root 3 plus pi. And I think that should be sufficient. If you want, you can calculate it out and put it as a decimal, whatever that works out to. If a squared does not equal b squared, what are both solutions of a squared minus b squared times x squared minus a squared plus b squared times x plus ab is equal to 0? All right, well, we got a couple choices here. We can use a quadratic or we can factor. I'd rather factor, so let's try that. All right, so let's factor this. Oh boy. Well, let's see here. Well, this one, a and b, okay, that's the easier part. Now I got to figure out how to factor this guy, but that's not so hard. You guys remember it's a plus b and a minus b. That shouldn't be that difficult. And therefore that's got to be x, that's got to be x, and then we got to think about the symbols. I think negative, negative. Okay, now what I want you to do is expand all this out to ensure that this is correct, because I could have been wrong, right? I could be wrong with the negatives, or I could be wrong with the whatever, but I'm pretty confident that this is right. But just for your own sake, since you're practicing, expand this out and see if you come up with that, and you should. Okay, so now that I've factored it, then it should be fairly easy. We have a plus b times x minus a is equal to 0, and we have a minus b times x minus b is equal to 0. So from the first one, we get that a over a plus b is x, and from the second one, we get b over a minus b is x. And that's it. That's pretty much all they wanted. What are the all real values of a for which the sum of the squares of the roots of x squared minus 8ax plus 14a squared is equal to 0 is 25. All right. So x squared minus 8ax plus 14a squared is equal to 0. Okay, so what is it? The sum of the squares of the roots. So I don't know what the roots are, so let's just call the roots r1 and r2. So the sum of the squares would be r1 squared plus r2 squared. Is that right? And they're saying that sum is 25, so this is equal to 25. Okay, so where do I go from here? I think you have to use Vietas here. This screams Vietas, actually. And for those of you who don't remember, not a problem. It says that if you have an equation of this form, ax squared plus bx plus c is equal to 0, the sum of the roots of that equation can be calculated by just b minus b over a. And the product of the roots would be, I think it's c over a? Yeah, c over a. So for this one here, the minus b over a would be minus 8a over 1, which is just 8a. And then the product of the roots, which is the c over a, that would be 14a squared over 1, which is just 14a squared. Now the sum of the roots are basically r1 plus r2, because that's what I had called them. And the product of the roots is going to be r1 times r2. So I think that should be enough to calculate this. Okay, so what do I do now? I think we just have to use that equation, the r1 plus r2 squared, and that'll do it. This will be r1 squared plus 2r1 r2 plus r2 squared, and then fill in all the information that we have, and then somehow figure out the value for a. Okay, r1 plus r2 is 8a, so put that in here, 8a squared. r1 squared plus r2 squared, well, that was 25. And then this 2 times r1 r2, well, r1 r2 was 14a squared. Okay, that's exactly what I thought would happen, is that we get an equation that will help us figure out a. Okay, so now this is fairly straightforward. This is 64a squared, 25 plus 28a squared. So what's that? 36a squared is 25. A squared is 25 over 36. And then when you take the square root, it would be plus or minus 5 over 6. So that's a pretty cool question. My carpenter was sawing off 2 pieces of wood, both of length x, so he could build 2 wooden triangles. What are all possible values of x for which the triangle with side lengths 3, 4, and x will be an acute triangle, while the one with side lengths 1, 2, and x will be obtuse? Okay, well, I guess we have a few scenarios here. I think we have 4. The first is when we have the 3, 4, and x triangle, and x is the longest side. And this is what, the obtuse one or the acute one? This is the acute one. Okay, so that basically means that if I drew a triangle, and this is 3, this is 4, and this is x, this angle theta acute is less than 90, right? So that's the setup. So what? Well, if x is the longest side, then x is obviously greater than or equal to 4. And because this is not a Pythagorean relationship, if it was, it would be 3 squared plus 4 squared is equal to x squared. But because it's not, it would be 3 squared. Let me think about this. 3 squared. Well, actually, you don't even need to kind of do it in the equation. You can just look at it and say x has to be, if it was a right angle, it would be 5, right? The 3, 4, 5 triangle Pythagorean relationship. But because the angle is less than 90 degrees, x has to be less than 5. That's just common sense. So therefore x is between 5 and 4. So that is the conclusion for that scenario. I'm pretty sure that's correct. Okay, let's move on to the next scenario. Same thing, we're still talking about the 3, 4, x triangle, but this time x is not the longest. And it's the same thing, the theta is less than 90, but I got to draw the triangle here to kind of show what we're talking about. So this is 3, this is x this time, that's 4, and this is the theta. Okay, since x is not the longest, that means that 4 is the longest. So that means x is less than or equal to 4. Or, yeah. Or x should be less than 4, actually. If x is not the longest, x should be just less than 4. Right? Okay, what's next here? I got to figure out the other boundary. Then using the Pythagorean relationship, 4 squared would be less than 3 squared plus x squared. Because if it was 90 degrees, it would equal 2. But because it's not 90, it's less than 90, it would be less than. And when you solve for this, you get 16 minus 9, which is 7. X would be greater than root 7. So this one would be root 7 is less than x is less than 4. Okay. So you kind of see where I'm going here. I've got to create these boundaries. Okay, now we move up to the 1, 2, and x triangle. And this time, same thing, x is longest. So kind of same way. Let me draw it first. So this is the triangle this time. 1, 2, and x, and this is theta. But this time we want it to be obtuse. So that means x is greater than 90. So if x is the longest, then x has to be greater than, hold on a second. 1, 2, and x. X is the longest side. X is the longest side. First, let's do the Pythagorean relation. Because it's greater than 90, this would be greater. So that means x would be greater than root 5. Yeah. X would be greater than root 5. And then, I got it. The triangle inequality. The maximum x can be is 3. So it's got to be less than 3, right? Because remember the triangle inequality that a plus b has to be greater than c? Yeah, so 1 plus 2 has to be greater than x. So x has to be less than 3. Okay, I was wondering, how do I figure out the other boundary? Okay, so there we go. And then finally we get to the last one, which is x is not longest. And the same kind of principle applies here. Let's draw that triangle again. So this is theta, this is 1, but x is not the longest, right? So I put x here, let's say, and that's 2. Okay, so if x is not the longest, so that means x is not the longest. Okay, so x obviously, in this case, I put it as, I guess, the middle value. Let's just use the triangle inequality. 1 plus x has to be greater than 2. So that means x has to be greater than 1. Okay? And then use Pythagoras. 1 squared plus x squared. If you compare that to 2 squared would have to be greater than. So that means x squared would be less than 3. So x is less than root 3. So that would mean x is greater than 1 but less than root 3. Okay, great. So we got them all. Okay, so now we have to combine these 4 to get a common, this guy, this one, and this one. We got to put them on a line, number line, and get the common. Okay, let's do it. So we got 5 here, 4 here, so that's this one. And then we got 4 and root 7. So what's root 7? Root 9 is 3. Root 4 is 2. So it's like 2 point something. So if this was 3, it'll be somewhere here, root 7. And root 7, between root 7 and root 4, right? That's completely different. That's here. Sorry, root 7 and 4 is what I meant to say. The next one is this guy, between root 5 and 3. So this was 3. And root 5 is, well, it doesn't really matter. It's here, so I'll just draw the line here. I don't want to overlap it because it'll get confusing. And then the last one is between 1 and root 3. So 1 and root 3. 1 and root 3. So 1 and root 3. Root 3 was even smaller, and then 1 is here, so that's here. That's completely out. What we are looking for is a common ground, and the only common ground I see is here. See, these two overlap, and that is between root 7 and 3. So that would be the solution. X between root 7 and 3 is the answer to this question.